Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore synthetic data generation, one of the hottest topic right now in the Gen AI ecosystem. Most of the people I'm talking to, they all want to generate synthetic data in their own industries, domains, etc. And it's really fascinating as well, guys, because synthetic data generation can help you solve some of the complex problem that exist currently in this world. Okay, for example, climate change, also in healthcare and some other industries. We can solve some big and complex problems with synthetic data generation. If you look at some of the LLMs as well, in the recent times, like for example, 5.3 or even you start the entire 5 family, by Microsoft. Microsoft always say that they have a better data quality for 5 models because they also use synthetic data generation. They use synthetic data to train these LLMs. And of course, there are multiple ways to generate synthetic data, and we are going to explore each and everything, guys, in this video. This is going to be a lengthy video. So if you are someone who does not want to spend at least an hour, this video is not for you. This video is for the people who wants to understand everything about synthetic data generation. We are going to start theoretically. We're going to look at how to generate data using both open source and closed source models, different frameworks like Distillable by Argila. We have Prometheus. We have a lot of other tools that can help you generate synthetic data. In the closed source one, we have Gretel. Okay, an European company, if I'm not wrong, probably I'm not sure which I think it's an European company. And Gretel or Gretel, I don't know how do we pronunciate it, but Gretel, I have already a video on Gretel. I think few months back when nobody used to know about them, and you can use that. You can also use LLMs stand alone, to just create synthetic data if you have a better prompt engineering skills as well. So you're going to cover each and every details. This is for beginners. We're going to cover everything about synthetic data generation. Let's jump into, guys, in synthetic data generation. Here, if you look at here on my screen right now, I have a notebook which is not created by me. It is by Distillable. You can see Distillable and Prometheus on DPU datasets. I'm going to cover this in the last. But let me first show you the magic of synthetic data generation. Now, what you see on my screen is a function that's called define generate reviews. And here I'm using OpenAI model. So I'm using GPT 3.5 Turbo for this example. And if you look at this, what I'm saying, I have a while loop. In the while loop, if it's not review is not generated, then I'm using 3.5 turbo model. I have a system, very basic system prompt, and then I have some code that basically gives me the synthetic data generation. We're going to look into this. Now we have some threshold values because when you work for these kind of problems, when you work for generating data, then you have to do a lot of business logics, to generate good quality data. You need to understand the domain, for which the data you are generating. So I have a threshold value, and what I'm saying here, if the word count is between 15 and 17 and this value, then print counted and then append those reviews. It should not be less than 15. So what I'm trying to generate here, I'm trying to generate reviews for products. Now if I want to build a model that can help me with sentiment analytics of products, finding out how many people like the product and classifier or generation. So those kind of use cases can be solved using these data if you do not have a data handy. And of course, you can generate data based on your own domains as well. Now, I'm just have a prompt text, write a 25-word positive review for wireless earbud, highlighting its battery life and number of data points 5. So you can set these two values, and you can see what I'm doing. I'm passing prompt text and number of data points, and once you run this function, it basically generates. So this is how it generates. Let me show you that. Now if you look at this, it generating review 1, review 2, review 3, review 4, review 5 with other perspective as well wherever required. Now imagine if you have your own products and you want to generate synthetic data out of it or for reviews, you can also do that. You can also go and generate some transactional data if you want to build a system that can identify the anomalies in transactions, some climate change related data, some healthcare related data, and so on and so forth, right? Now I will give all of this code, but this is not the main agenda of this video, guys. The main agenda is to help you understand how synthetic data works, what is synthetic data, what are the frameworks, tools available, and then in last we go through this code basis. Let's start first of all with our journey, guys. So let me just do one thing. I'll go inside my pictures, and I have a folder called synthetic data generation. And I'm also going to walk you through. But here I have my tab as well. We're gonna do a tab route today. We're gonna explain a few things. Let me bring up my other monitor here so I can see it. Synthetic data generation. I think I am able to see that. Cool, guys. Now we're gonna jump into it quickly here. And if you look at this picture that I opened, this is how synthetic data generation process starts. You have a seed data query input, then you have an LLM that basically takes as that, and then you synthetic data gets generated. Then you do a post processing. You both have to do pre-processing and post processing to get better quality data. Now, post processing where you do refinement, filtering, PHI or PII information, sanitizations, redactions, and so on and so forth, right? It can all go in. And then you have validation and testing where you can again use an LLM as a judge. So LLM as a judge, all the evals company are doing it, by the way. And we're going to talk about this, all of this. But let's start with the definition first. What do we mean by this, and what are the different techniques we have? Now, imagine you are solving a problem that identifies some of the personal identifiable information. So I'm going to write here PII. Now you have PII information. For example, if you have an Excel sheet of called name, and then you have geography from which country, and then you have SSN number, or I'll probably remove SSN because that's in US, and I'm gonna call it ID number. Now, if you have this sample data, and one of your client has shared the data with you and they want you to train a classifier model, but they say that, hey, look, you cannot use my data as it is because this contains PII information. Now, in that case, what you can do, you can generate a synthetic data based on the same schema. So in case your schema is name and your schema is geography, and then you have IDs. So there are multiple ways. So what, for example, if one name is Sonu, country, India, and I have some 123 DE number, and these are all my confidential details. I do not want to share this with the company that I'm gonna share my data with. But of course, they cannot use the same data. They can use this as a sample, of course, to generate a new data out of it, or a data that might look similar but it's fake, okay, which is not there. So, for example, I can just replace this with somebody XYZ, and I can just replace this with some country, like Australia or something, and then I also replace this ID number, for example, 89XYB or something, and I create this data. Now, to create this kind of data standalone, you can use a tool called Faker. So Faker is a Python library that you can immediately use to create synthetic data of these kind of patterns. Basically looks at regular expression. This is how the underlying concept, not rocket science, guys. Algorithms are always easy, trust me. Coding, programming, they're all logical thinking, the way you think to solve a problem. If you look at these kind of names, geography, that these are all can be solved using regex, using regular expressions, using basic natural languages. That's what Faker does. Now, this is not what we are going right away. Let's look at self data, synthetic data generation types. So if you talk about the types, which is very important, and the entire industry is talking about it, and after we got LLM, guys, the things becomes more easy. So the first thing is called distillation, and the second thing is called self improvement. These are the two types, very high level categorization of synthetic data generation. How do we generate, and using LLM, of course, I'm talking about, see, my entire focus is to always keep LLM in loop for this video, okay, because I assume that you're going to use large language model to generate synthetic data because it might be really beneficial. At the same time, it might be the data that you generate might be a bit biased as well if you don't have a better logics while generating the data. But this is what self distillation and self improvements are. Now, distillation is a method of creating synthetic data using LLM, which is very easy to understand and is said to have a larger number of parameters and higher capability. So first we're going to look at distillation here. So let me just write quickly the definition, a very high level view of distillation. So when you use distillation, it basically have a large number of parameters, but the accuracy or the understanding is also very high. So the capabilities is higher. So understand distillation like one model is going to teach the other model, or the one model is teaching somebody to generate something new. That's what distilled means. So you are distilling something right out of it. Now self improvement means the model learns itself. Okay, so there is a pictures also, I can show that in a bit, but that's what distillation is. Now when you use distillation, so this synthetic data that we generate using this is closer to human created data. So distillation is closer to human created data. So when somebody creates data manually, we also do a lot of annotation, right? If you remember, humans are always going to create better data. We have seen that on surveys and stuff, but now also looking at the machines, for example. Now using a 7B model, for example, it can improve the performances. So this is on the distillation. Now, very high level on self improvement. The other technique, if you use LLM, it has to be self improvement. Now, in self improvement, it create a data set with the model you want to improve. So, for example, if you want to improve Llama 7B or Llama 8B, which is the Llama 3, for example, if you want to improve that, you have to improve yourself with the data set. So, I'm talking about the model. Okay. Now, this is often used to train models. So, let me just write it. Don't have a model larger than the model. So, for example, not for 7B, but for example, a 70B model. So, let me just write it over here quickly. So I'm going to write create a model that create a not a model, create a data set. So let me just write it here. So create a data set with the model you want to improve. Now this is on self improvement. Now let's focus on distillation first. This is a high level information about two different types of famous synthetic data generation types. Now, if you talk about distillation, it's one of the most famous techniques right now in industry. Everybody was talking about data distillation, knowledge distillation, and so on and so forth. So let's talk about distillation here. So I'm just writing distillation. Now, distillation have also multiple techniques, guys. So we're gonna cover a few techniques in distillation. So on very high level, if you look at, there are multiple techniques for distillation as well. So one is self-instruct. So that first is self-instruct, and these all can be achieved using frameworks like Distillable by Argila.io. We're going to talk about that. Prometheus also supports that, and different open source and closed source frameworks as well. Now, one is self-instruct, which is like a basic form of synthetic data generation. The second is Evol-instruct. So second is Evol-instruct, which is a more challenging data set. So it's a bit challenging. Let me just write it over here. Then third is lab, and I'm going to talk about this. This is really interesting. It's more diverse. So let me just write it. And this is good for chatbots. If you have a chatbot use case and you need data, you can look at lab, which is the most diverse data sets. For building a chatbot for generic users, guys, your data sets needs to be really diverse. The next is uh, more task oriented. So I'm going to write it task specific. So for example, this can be open math instruct, which is if you want to generate these kind of data, so that is task specific. And then last one is knowledge specific. So last one is knowledge specific QA. So last one is knowledge specific QA data set. So these are the 5 ways you can, distill, okay, your data if you want to generate that. Now self-instruct is the most easiest one to create. Okay, if I show you some of the pictures of how the self-instruction works. So let me just open this probably, and I can make this a bit bigger, guys. So I don't know if you can read this. So let me just make this. I downloaded this from internet. This is not created by me, to be honest. The credit goes to the creators. Now if you look at this, it has your step one, which is instruction generation. Okay, your instruction generation, you write, give me a quote from a famous person on this topic, and then you give it to a language model. It basically does a classifications and task identification. So basically classifying the prompt, over here. And then if it says yes, then find out if the given text is in favor of or against abortion. It looks at class level and then inputs, then goes into filtering, and then it has some seed task instruction task pool, and then create the data for you. And if it says no, first is output first, then is the input first. The importance of being honest, input and output, Thomas Jefferson, right? So this is how you create a self instruction data sets, and we're going to talk about this later. And if you look at distillation, and from this chart, I got this from somewhere on internet. This is a very good picture to understand distillation and self improvement. If you look at here, distillation is somebody is supervising. It also works good for supervised fine tuning or SFT, because those are censored fine tuning that you do, because then you are generating a data in somebody's supervision. When I say somebody, of course, might not be a human directly. That's what the distillation is, that you're teaching somebody, and self improvements to learn from itself, right? That's what a model can learn to improve itself using some data sets. Now this is what the picture is, but we're gonna go inside a bit detailed. Now for the self instruct, the basic process is to generate a data set by sending a request to the LLM directly. For example, like in this case that we did with OpenAI GPT 3.5 Turbo, right? You can see what we are doing here. We are saying write a 25 words positive review for a wireless earbud highlighting its battery life. Now this is nothing but these are the self-instruct synthetic data generation. That's what we are doing here with this case. Now, if you go to this picture, I don't know if I have opened. Now here you can find out some seed instructions per task. So let me just to write it something so you can also go a bit deeper into it if you want to understand. This is how the this is how the schema can look like. Okay, the template. Now you have an instruction, and you can give any instruction. Okay, over here. So I'm just writing put your instruction. Okay, let me just cast that. Put your instruction, and this is your instruction. Then you have an input, and you basically write your input something like 10x plus 5 equal 10. You have a math equation, and then you have an output. This is how you define a schema, so you can do 10x equal, something. And if you look at this, it's 10 minus 5, whatever, 5, 10, whatever it comes. Okay. So 5, and I'm just solving it over here, but x might be 5 by 10, and it might become 0.5. So this is how you define instructions. So these are the seed task. Okay, so these are called seed task that you see. So seed task consist of a pair of instructions, input and output. That's what you see it over here on the image on the left hand side on top. This is called seed task, and that includes samples. You can see it says 175 seed tasks, because the model can learn from the patterns itself. Okay, now by sending the prompt to LLM with some example that's are included in the seed, the subsequent task will be generated. So it will generate the upcoming task that you have. That's how the self instruction works. So I hope you understood the self instruction part now. And all of this you can achieve it through our disti level, which is the best framework to work with. Now let's go a bit difficult thing, which is evolve. So the next is Evol-instruct. Now Self-instructs was effective in generating datasets, but it's difficult to use because the difficulty and complexity of the tasks are close to the original seed task. And that's why when you want to fine-tune LLM for more difficult problems, you will need to manually create complex and difficult seed tasks. Now imagine somebody sitting and creating 500 seed, having instructions, input and output. Again, that's a tedious task to do, right? That's where we bring up Evol-instruct, and you know and self-instruct, which generally does not give you better accuracy or high quality data, and that's why we adopt two different ideas in that case. So the first is, let me just write it. The first is separate the timing of generating prompt and answer. So let me just write it over here. And the second one is add a process. Add a process to slightly increase the difficulty. Slightly increase the difficulty of the prompt. Now, by repeating this process, you can increase the difficulty of the prompt. So let me show you this image so you understand a bit better. Now, let me just make this a bit bigger. I hope this is clear. This looks good. I hope you can get this. Now, if you look at this, it has a lot of things happening. The initial instruction is 1 plus 1 equals what? Now, it increase reasoning. If you look at this first, increase reasoning. What is the value of x if x cube plus 2x plus 3 equal to 7? It's very related because it has numbers included. You have a simple equation which is 1 plus 1 equals what, and if you go deeper it says in what situation does 1 plus 1 not equal to 2. So this is deepening, right? Because if you look at how people evaluate a large language model, they always ask what is 2 plus 2. LLM says 4, but there are some scenarios that can also make other sense for 2 plus 2. Now, if you look at add constraints, how to prove 1 plus 1 to 2 in the Goldbach conjecture. Now, these are the different prompts, which is complex prompt that has been, created for the LLM to generate better quality data. Now you have other techniques. You can look at over here. What is the speed of light in a vacuum? This is one instruction, blah, blah, blah. How is the speed of a light in a vacuum measured and defined? How many times faster is light than sound? So increasing the reasoning capabilities, the thinking ability of a language model. If of course thinking is the wrong word, it can't think, but the reasoning capabilities, if it can reason well. And so you can look at in this image, right? It can go really deeper, can create complex prompt as well. The difficulty of the seed task. Now we let LLM do increase the difficulty of this prompt, and there are several ways to increase the difficulty. You can add constraints, you can increase the depth or the breadth of the question. So you can increase the depth, and that's what you see here in breadth evolving. You have here you have deepening, increase reasoning, in breadth evolving, complicate input. So these are the different ways you can create the logic to uh, increase the complexity of the prompt. That's what it does. Now the third one is lab. So in the uh, lab is interesting because, as I said, right, it gives you more diverse data sets to create. Lab's full form is large scale for bots or something. Okay, so let me just. So this is how you basically write it. So it's called large scale, if I'm not wrong, alignment of bots. So the lab is taken from this particular three words or three letters, by the way, excuse me. That's L, and then you have A, and then you have B. So this is how lab has been. So basically, it creates detailed hierarchical classifications. And for example, top classifications can are like knowledge tuning and skill tunings. And probably you can find some pictures. I don't have a pictures for this, but you can get it. Now, for chatbots, you would have heard about most of the chatbot in production has gone rogue. They started responding stupid answers. Of course, you can bring up some guardrails on the post processing or also in the pre processing. You can bring up moderations, content moderations. You can bring up different types of payload splitting preventions, different types of token splitting preventions. These are all the guardrails that you can put in the system. I have a guardrails video, how to stop prompt injection, how to prevent prompt injection. Have a look at that video as well. But for the lab, it ensure task diversity. So for more diversity, so let me just write it over here. So okay, I'm not casting, but you can look at here now. Ensure task diversity. So let me just do that. This is what lab does. It so self and evolve. These are good, but they can be sometimes can be biased as well. And to address this issue, just to cut the biasness, what we do, we classify. So let me just write it over here. We classify tasks in advance. So classified task in advance. That's basically called hierarchical classification. So you are basically classifying the hierarchy in tasks, and limit the tasks example. That's the second thing. So limit the task examples given each time to only those from one task classification. So that these are the two things that you do. And the good thing about this is that the prompt can remain the same as in self-instruction. So this you can use this as on an extra layer on self-instruct. The only code you need to modify is the logic for selecting examples. So you can just use self-instruct plus lab together if you want to create a very high quality data sets. Now the self-instruct, what you can do, you can keep the prompt as same. So prompt remains same. So prompt remains same, and what you can do is now the code you need to modify is the logic. So logic for selecting examples in the previous one. So logic for selecting examples. So let me just write it over here, selecting examples. So this is how you can also combine it. Now the next two are a very domain specific. If you want to generate some specific QA, like you have task specific and knowledge specific QA. There are these are basically a way to generate high quality specific data for different tasks. So if you look at Open Math Instruct, for example, let me just write quickly. So if you look at Open Math Instruct, so let me just write over here, Open Math Instruct. Now these are again based on evaluation benchmarks data sets. So you have evaluation data sets for benchmarking, right? So for example, if you look at uh, uses this uses the trend data of the math benchmarks. So if you look at this, there's a math benchmark data, and that's called math GSM. If you look at, I think this is available on MMLU as well, if I'm not wrong. So this math benchmark, math GSM 8K. So it's a benchmark data. It contains both problems and answer, and then we evaluate LLMs on top of it. Now, in response to this, we create a data set that contains problems, solutions, and answers by generating solutions using Python with LLM. Now, Mixtral was to create the problem. Okay, so you can use Mixtral. So if you look at Open Math Instruct, they use Mixtral. So they use Mixtral here for this data sets, to create the problem. But even with Mixtral, it is difficult to solve the problem with a perfect score. So the following methods you can use. So let me just write it over here. Have a student solve the problem. So you need a student solve the problem as many times as possible and use the correct answers from the students, and and then evaluate. So basically you can employ a technique to generate a solution when you already have only the prompt and the answer. So now imagine RLAIF, guys, reinforcement learning with AI feedback. We all have been talking about RLHF and stuff, but if you look at these kind of synthetic data generation types, RLAIF might seem possible, right? It might be a good thing for future. You can use LLM as a judge itself. It can the AI can give feedback to improve systems as well, and it can keep on generating. So you can build an entire system using all of these techniques, but might be a bit costly as well. Now you can create knowledge specific QA. You can use multiple data sets for that. Okay, so if you want to create a lot of knowledge specific data, there are a lot of base data like common crawl, Wikipedia, Wiki, and you can use all of this. So then we have Wiki, etc. You can take all these base data, and base data is nothing but, guys, keep remembering it, what I'm saying. They're all seed tasks. So you can create seed out of it for the self-instruct, if you remember, where we created a pair of instructions, input and output. So you can use this common crawl, wiki, etc. Uh, and have a system to create a question answer related to the text. It's very specialized. You can use that. Now these are way of creating distill or performing distillation. In the self improvement, it's a bit different than what you do it. So I'm not probably going to cover it. Now let's jump into and see what are the different ways you can create these synthetic data. So if you look at here, the first thing, okay, there is a library called Distillable. So let me just go a bit on top and show you. It says Distillable is a framework for synthetic data and AI feedback for AI engineers that require high quality outputs, full data ownership, and overall efficiency. Scroll down, it says synthesize data for AI and add feedback on the fly, blah, blah, blah. This is the library you have to use. That's a very good library, guys. Supports different LLMs. You can see you can use Grok, which for free for now. If you want to generate that, you can use open source, closed source. Now, what I'm going to show you is, let's see how we can, create a DPO dataset with the smaller models like 5.3. So I'm not going to write the code. I'll just explain it. The a very detailed code is available already. And before this, let me just go into Gradle. If you want to use a API driven solution to generate synthetic data, then you can use Gradle. Of course, they gives you for free. They give you for free as well for some trials and stuff. You can use it up to some rows and column. This is a very good way to generate data if you are not working with really sensitive or confidential information. If you want to try it out for your learning, you can use synthetic data for everyone. So you can see 15 free credits per month and then $2 per credit. So for 15 free credit, your 15 free monthly credits are enough for 100K plus highest quality synthetic records, 2 million transform records, 2 million plus PII detection records. You can understand what I'm saying. Now you can also use this for PII redaction as well or sanitization as well. You have some personal identifiable information. You can use this as well. And now the next thing is, let's come. Okay, I mean, this is fine. You can reconnect it. This is okay. Now, to use this library, you can see we are using Distillable, Argila, and Llama CPP. So you basically install these. Once you install it, I'm logging with my Hugging Face Hub API. And then if you look at this, this is where you define your project name. You have project name is your project that you want to create because you can push it on Hugging Face. So that's why they are asking about these parameters. You have project name, you have input dataset repo ID. So give it a input dataset repo. Now, if you look at this, what it says, what supervised fine-tuning dataset on the hub should we start from? So basically the seed, guys. Remember the seed I was talking about, the seed task, the base questions, prompts, whatever you call it. Now that dataset over here, and then what are the instruction and response column named in the dataset? So whatever you select here, because you are generating a DPO, remember it. So if you select here, Ultra Interact SFT, you have to look at inside the dataset. So let's go inside this. Let me explain that to you as well. Open it over here. Oh, excuse me. And if you open this, the viewer is not available. Say the dataset viewer is taking too long to fetch the data. Let me just try to refresh if this works, but I think it will not work. Okay. If you go to viewer, uh, something wrong with the viewer, so I cannot show you the column from here as of now. Or let's see if they have given something below. Yeah, so if you go back, okay, on here, it says response instruction. Now look at these two things. So response and instruction, you have both the things. If you look at here, response and instruction. So if you select this data set or any other data sets, you have to basically name that. And then in evaluation rubric, which is factual validation, because evals are important, and they also have an evaluation model. If you come down, let me show that. Now they select a model. So if you read what they're saying, define the quantized model that you want to use for generation and evaluation. They are using quantized because if you look at the foundational or base model, it might take a lot of time and GPUs compute to basically generate all the generations and then evaluate it. It might take up to a day as well. Uh, but having said that, right, if you look at here, they take a GGUF model for evaluation, which is from Prometheus, and then the text generation, they're using 5.3 Mini 4K, which is a very good model. You can see 5.3 Mini 4K instruct. And then this is fine. There are some parameters that goes here, inference params called temperature max tokens and so on and so forth. And then you define human feedback test in Argila. So basically you can look at instruction generation and then you have some questions. How would you rate the quality of the answers? You can also use LLM as a judge here, LLM judge, whatever. There are different frameworks, libraries available. How would you rate the quality of the answer? It says 1, 2, 3, 4, 5. The values from 1 to 5 to rate the answer, and then gives a feedback. So feedback on the quality, and it has a guidelines. Please read the question carefully and try to answer it as accurately as possible. And you can also push it on your push using push to Arzilla as well. You can see name, project name, workspace admin, blah blah blah. And then we define the distillable pipeline. So this is the pipeline that we have defined. You can see here in the step instruction generations, feedback, results, and the model name. So basically everything goes here. It says DPO to Argila, it is a function. You are using everything over here. You are generating instruction generations. Prompt chosen rejected because you are generating a DPO data sets, performance alignment, direct performance alignment, and it accepts these formats of data sets. And you can look at chosen, rejected, and then it has some suggestions, and then append the records. You create a data set, add the records in record and yield the inputs, and then Prometheus, etc. will be again be used. You can see text generation with Llama CPP using Phi3 over here. And this looks nice. And then for evaluation, you can see this model for evaluation. For each answer that it generates, it has to evaluate as well. And it has some parameters and for on what thing it should evaluate. So it should evaluate on factual validations. You can have a look at there, and then you use some push to Argila method to push it to Arzilla. You can also do it on Hugging Face, and then just call the functions and then run the distillable pipeline. You can see run it, and it takes a bit of time. So I'm not going into too deep here, okay, inside this, but you can use this notebook if you want to generate a DPO data set using Phi3 Mini. You can use that to generate. You can use Grittle if you want to do it. They have a very good documentation. If you go to examples, a lot of documentation to read from, guys. And if you look at here, different use cases, synthesize tabular data. So if you want to create a tabular data, go to SDK. You can use Python SDK. You can see that's called Grittle client, and you can generate over here. It generates, synthesize. You can also redact PII. You can remove PII, by the way, as I was talking about earlier. And you can see this is how you can use it. And there you can also look, they are also using Faker. So remember we talked about Faker, we talked about Grittle, we also seen OpenAI. Here we are generating using OpenAI as well. Self-instruct generation that you see here might not be that relevant, but yeah, this is how you generate, guys. So you have Grittle. Feel free to use, go to Arzilla, have a look and generate and see how you can do it once. This is what I wanted to do in this video, guys. I wanted to create a bit of awareness within you when it comes to synthetic data generation, different ways, self-instruct, Evol-instruct, lab, question answering, really task specific QA, and you can use different tools and frameworks to do that. I'm not writing any code in this video because those notebooks are already available, so it doesn't make sense copy paste and just write it from there. But if you have any question, thoughts, or feedbacks, do let me know in the comment box, and I will give all of these code notebooks and the code base that we saw for OpenAI in the GitHub repository. I'll give the link in description. If you like the content, please hit the like icon, and if you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in your future. Thank you so much for watching. See you in the next one.